This is my DIY mill, and this is the flood cooling enclosure that we're going to build today. So stick around. So this is the plan. I plan to fold some sections out of sheet steel and kind of attach them to the outside of the milling table. So I'm going to start with some sheet steel, mark it all out, and then we will proceed to fold and screw it all together. This is a sheet of 50 by 100 centimeters of 0.8 millimeter steel, which is 22 gauge, I believe. So I'm just trying to figure out how best to utilize this sheet of steel. It's just standard bodywork, car bodywork grade, and it's covered with a small layer of zinc, I believe, which makes it really nice and shiny and a little bit rust resistant. So I'm just marking out where to cut and where to fold. So this section is one of the side sections. Well, so once I finish that one, I'm going to copy it over to the other side. This is my manual sheet metal cutting and folding machine. I haven't really used it that much. I bought it years ago, and as you can see, it's a bit rusty, but it works great, especially for thin material. So I'm just arranging the fingers so they're all in a line. And yeah, let me just get all that crap out of the way from the back of the machine. So it cuts through it with a little bit of effort. The cutting blade isn't aligned properly, the table, so towards the left side you can see it struggles a little bit. But it's a great machine, to be honest. It's kind of a hobby grade piece of equipment. It doesn't take up that much space, which is why I kept it. But the folds are nice and straight. It does mark the sheet a little bit where it's folded, but I didn't put any grease on there, so that's to be expected. The folds come out really well, and I'm just gonna copy everything over to the other sheet. So I'm just lining it up, triple checking it, and folding it. So it lines up really nicely on the sides here. I've decided where the hull should go, so I'm mounting the two wings, if you like, to the table at a slight fall angle, so it's slightly angled to the back of the machine, and that's going to be secured with some M5 screws. Well, that didn't go so well, but I did manage to get the broken tap out, so then I decided to go one size up to M6. And it fits really nice, and it's flush with the table. Now the piece that's left, I'm marking out the front and back sections. This piece of steel was 50 centimeters by a meter, and it's almost all used up, which is great. So this time it cuts a lot easier because the piece isn't as wide. And that's come out really nicely. So I'm just test fitting it to the back there. It will need a couple of sections cut out so the steel overlaps the side. This is the drain for the back of the tray. This is something I figured out the press would be good for. I can just get a piece of aluminium and just push a socket through it, and that will give me a nice little punch sort of section to slide a little tube through, which I can then stick a piece of hose on it. The first time it didn't go so well because the socket was actually just a bit too big, and the aluminium just kind of smushed itself into the threads on those big nuts. So I'm having another go, and I'm using the original failed attempt as the form for this next one. So I'm heating up this aluminium because I don't want the edge to crack. Once I could see the aluminium moving under the heat, it kind of becomes a little bit liquid. I then take the heat away and push the little socket through. Then I use a piece of steel just to flatten it as much as I can. And a piece of tube, just a piece from an old curtain rail that I found. This is the theme here. And that just pushes through really easily. This press, by the way, is a 12-volt hydraulic press, which I built out of a old hydraulic cylinder from a digger. So that's built from scrap as well, I guess you could say. And it works really well. Here I'm drilling the hole for the drain. Just with a conical bit so it doesn't snag the material because it's so thin. Drill 4 holes, just eyeballing it this time. Thread them, M6 again, and I'm just cutting off the burrs from the back of the aluminium. And here it is. I decided to use cap head stainless screws in the end. So I'm just using a little bit of stainless steel mesh here, just to kind of act as a bit of a strainer. And I'm using the file there to kind of push the mesh out of the way so the bolt can come through. And here it is. Bolts together really nice. For the front and the back section, I've just drilled some 6mm holes. I've tapped the stepper motor support here because the sheet steel just sits on it, and then done that same thing to the back as well. The front and the back aren't actually secured. Well, the front is, but the back isn't secured to the table. It's just secured to the wings. I had some 2020 left over, so I decided to use that for the uprights. So the plan is to have 4 uprights and then slide some sheet material in as the sides to the enclosure. So I've just marked them, cut them. I've marked where the hole should be, which the geometry of 2020 is really easy. It's just, you know, the hole is 10 centimeters away from the edge. I'm making sure it's fairly square. I mean, the sheet metal isn't really that straight in places, so it's just a rough measurement. And I've drilled the holes for the little M5 screws that are going to slide into the 2020. So then I've applied a bit of sealant to the edges and screwed the whole thing together. Now comes the wiring. So very simple. This is a crappy sort of kit from AliExpress, including a pump. So I've just cut the plug off of the end of the pump. I'm putting a little crimp connector onto the end where it's going to go into the inline switch. This is a light switch, but because of the low amps involved, it's absolutely fine for the pump. So it's a manual switch. Eventually I might put a solid state relay on it and have it controlled by the machine control software, but it's fine for now. Just printing a label, just for niceness. And here it is, all complete. For the reservoir, I decided to use one of these 25-litre containers. This contains some car wash chemicals. It was thrown out at the back of a car wash, and I just asked if I could have a couple, and they said yeah, cool. So I took a couple. Perfect kind of use case. So I decided to chop the top off because it looked like the top could actually fit onto the bottom portion because it kind of flares out a little bit. So yeah, just use this jigsaw and cut a small strip away, and yeah, with a bit of perseverance it does fit. It's only really just to stop evaporation as much as possible. It won't, support the weight of the liquid. For the hose routing, I'm kind of just winging it at this point. I decided to just cut a hole in the top for the big return hose and small feed hose as well. I decided to submerge the pump in a kind of a hanger, so it's lifted away from the bottom where any swarf might collect as the return hose is feeding the bottom. I'm just measuring here to figure out the dimensions of this bracket. I pulled out a nice sheet of aluminium I had left over from another project, and I started measuring it, and then I kind of thought, you know what, this is too good really, and it's a bit thin. So I decided to use something else. A little while ago I got a bunch of these dye bond sheets. They're aluminium plastic composites, so it's got a thin aluminium sheet on the outsides, and inside is a core of, I don't know, ABS or something. Yeah, I decided to use that instead. It sort of breaks once you fold it, so it breaks on one side, but it's still strong enough to support the weight of the pump, and it's super easy to bend. Because of the shape, my machine didn't have enough clearance, so I had to kind of like half bend it and then fully bend it into shape just by hand, which yeah, was quite easy to do. So once the rough shape is bent, I then tried it in the lid and decided to just chop off those corners to make the U a little bit squarer. And yeah, a little bit more. Drill some 6mm holes, put some M6 hardware in, and yeah, it looks quite good, I think. It's a little bit flimsy, but it does hold the weight of the pump perfectly. The pump suckers just suck onto that bottom portion because it's really nice and smooth and glossy. I fed the switch and the cabling through the filler, and I cut a little slot in the filler to accommodate the power cable for the pump, and I'm just connecting the hoses. For the cutting fluid itself, I decided to use this Sabersol 2B by Smith & Allen. It was available on Amazon. Next day, done. Mixing somewhere between 5 and 10%. Now it's all connected up. Just gonna hit the power. And the pump is more powerful than I expected. Yeah, straight away I've got a leak from somewhere, and surprisingly the leak wasn't mine doing. It was the wonderful quality of this block. It looks like it's the core plug, which annoyingly I can't access now because I've just thread sealed the frickin' plastic in, and the drain is doing perfectly well. Eventually the T-slots in the milling table will get completely flooded, and that's okay. I didn't want to drill a drain hole into the actual table itself. Yeah, I'm just going to have to live with that. And the switch is working, obviously, it's a switch. I'm going to either magnetically mount it somewhere or just command strip to the machine. And now we're gonna go for a test cut. This is about 8 and a bit millimeter thick steel. I don't know the grade, but yeah, I'm just gonna go slow and see how it performs. So this is about a 1 millimeter width of cut, which on a 6 millimeter end mill is, I don't know how many percent, 15 or something, roughly. Depth of cut, 8 and a bit millimeters. RPM, about 1,000. Feed rate, about 50 mil a minute. It starts off a little bit loud, but then I adjust the RPM so it's just fast enough to cut quietly, not too fast, so it's rubbing. Yeah, it's doing really well. Once the machine is set up more and I learn more about it, I'm obviously going to push it a lot harder. This is quite easy for it. Now I just need to add the sides because, yeah, it's splashing everywhere. And the finish is pretty good. Now the only thing left to do is put some panels into the 2020 grooves. A 6 or a 5 millimeter panel will be perfect, but I have this die bond and it's about 3 millimeters, so it's a bit loose, but it will be fine for now. I can pack the sheets with some 3D printed wedges and it fits perfect. Here it is after the sides were done, and it's pretty much finished. I still need to get the front, but I have the material on order. I just wanted to do the video before waiting another few days. So I'm really chuffed with how this turned out. The sides contain all the spillage and it's draining really well. The jet is powerful. The leak is unfortunate, but I can live with it. So I hope this video has been useful to you. If you enjoyed it, you know what to do. If you have any questions, just drop me a comment. Thanks for watching.